This video, you can notice that the quality is kind of dropped a bit. That's because I'm taking this from a stream. So what we're going to actually be doing is, first and foremost, we want to make a gear that plugs in right here and can be powered externally. But the first thing we're going to want to do is we're going to want to actually just get a gear into this file. So what we're going to do is we're going to go to Tools, Add-ins, Script and Add-ins, or alternatively you could hit Shift+S. Click on Add-ins, click on one of the spur gear options right here, click Run. You'll know it's successful because it will say the spur gear command has been added to the Create panel in your model workspace. Click OK. Go back to Solid, click here, and right there you can see you now have the spur gear command in your thing. Sometimes you have to click and unclick the pin to toolbar to get it to show up. So I always use metric. I never touch the pressure angle. The module is, you can think of it as how many is basically the multiplier of how big the gear is actually going to be. And that's, let's do 15 to call it safe. The backlash is basically a cut into the tooth. So if you have no backlash, in theory these gears would mesh perfectly together, but with backlash there's a little bit of shake. For 3D printing, you want a little bit of backlash. I'm just going to put 0.5 here. This root fillet, you can see up here, it's pointing to right where it is at, is this little curve right there. You want that to be as large as you can make it. It just helps strengthen the tooth a little bit. All right, gear thickness, how thick the gear is, we're going to set that to 5 for now, and we're actually going to make there be no hole in the middle. Click OK, and it will generate your gear for you. It actually draws it, so it's not like a feature that you can go back and edit later. So if I wanted to change something about this, like, oh, I actually needed it to be 16 teeth, I would just have to generate an entirely new gear, which when you end up building a lot of things and they end up getting nested super deep inside the model, it's kind of a pain in the butt to go and fix. Now that we have this gear, we need to make a way for it to, 1, be held in place, and 2, interface with the rest of the escapement. So how the escapement works is it has this pin in the bottom right here. Let me isolate it, or let me just activate it so you guys can see a little bit better. And it is what actually bridges the connection between whatever's powering the escapement and the escapement itself. What we're going to do is first activate the spur gear component, and we're going to make a sketch on top. This will be, for now we're going to set that just to be 15, and we're going to extrude it up 10. You can see that this plugs in at 5 millimeters thick. Now, if in a lot of the videos where I'm assembling these, you see it be a lot shorter. That's just because I am using an old model where I hadn't extended it yet. If you are going to be modeling your own attachments to this, I highly recommend that you actually download the Fusion 360 files. I'm going to be posting those on Gumroad, and they're going to be just set to like pay what you want. So they're completely free. If you want to pay, it's just if you want to like show a little support. It's not required at all. But you can see that this plug goes in 5 millimeters deep. What we're going to want to do is make another, continue. I did not mean to click and drag that at all. So we're going to make an inscribed polygon, and I cannot for the life of me remember what its dimensions were. This is another good reason why you'll probably want to download actual Fusion 360 files because it's a pain in the butt to remember everything. So that is 8. 8. So well, that's 4 actually is what it would be. Yeah, 4. And then with these guys, when they're blue, they're not constrained, which means that they can move. They can be moved by like clicking and dragging. So you can see how I'm able to move this. You want them to be fully constrained because otherwise, if you accidentally click and drag, you'll move stuff and you can change dimensions and things like that. So with these polygons, I always just set the radius for the inscribe and then go up here and click on one of the constraints called horizontal/vertical. I just pointed at my own screen, which does not make a lot of sense. So we could actually shrink this down, which I'm probably going to go back and do, but not quite yet because I haven't modeled anything and it won't change anything yet. So we are going to want to extrude this down 5 millimeters. At this point, we could take this gear right here and plug it onto the bottom of our tourbillon, which then if you meshed it with another gear, in theory it could work. If the gear is not supported in the bottom and there's no frame piece in between between the bottom of the tourbillon and the gear, then this whole thing can fall down and that's not good. So what we're going to want to do is we're going to want to have a support piece, or really just like a plate that sits right here that actually the tourbillon rides on. And we're going to want a hole in the bottom of the gear so that way to receive sort of like a pin that it can rotate. It won't be quite a through axle, but it will rotate on it. I'm sure that the terminology is just an axle, but I'm a struggling YouTuber. I don't have to know stuff. All right, so I shrunk that down to 12 just so that it uses a little less plastic. And now we're going to be making the hole in the bottom. Now I'm going to make that be a 10. It could probably be a 5 mil axle, but I want it to be just a 10 because I personally would prefer to have it be a 10 because it's going to be handling quite a bit of torque. So I want it to be pretty beefy. All right, so let's go into Inspect, Section Analysis. Click there. So that way we can have a side view of everything. So you can see I have a little bit of a barrier in between this guy, between the pin that, what do I call? I call this the lower lock, apparently. So I have a little bit of a barrier between the lock and the gear. You could have that go all the way through. I don't really, actually, yeah. So what we're gonna do is we're actually gonna go back into this and we're gonna make it go down by just 2 more millimeters because this will still not reach. So this will not reach down into this chamber for the axle, but it will reduce support material and friction potentially. This is essentially what you would need to model for powering your tourbillon from something else. But I'm going to go through the rest of it until I actually get to the point where I can just insert the tourbillon model, just so that you guys know what is going on. So this guy, actually, you know what I'm going to do? I am going to insert this into the current design, and I'm just going to keep it hidden. Oh, hey. Hello, Rackagak. I'm making a modified thing for this. Here, if I turn that off. you can see this gear right here will plug into this, which is the bottom part of the escapement. Also, oh, why is Minecraft open? I'm AFKing. Back to actually making the gear-powered tourbillon. I'm going to be creating a new component, frame, and I'm just going to be titling it frame piece. I do not want it in there. I want it outside. So the frame piece has to have holes in it to accept this guy right here. Here, I'll do. So if you hit Shift and N on the keyboard at the same time, it will change all of the colors of all the different components to be different, so that way it's nice and easy to tell them all apart. But I will need the frame piece to have holes to accept these pins, and that's actually what's going to hold the frame in place. But I want to do that without using this as a reference. So in the end, I want to be able to remove this whole component and not have it mess anything up. So we're going to go into the frame component, make sure it's activated, click here, and draw an 8mm circle right there. It's just the same thickness, it's just the same diameter as the inscribed hexagon. And then, because this is just the frame piece, it depends on what actual thing you're making. So, but going back to this original model so that way we can get measurements, we need to put in these 3 holes. Looks like we go out 42.5 for the outer thing, and then we add 12 to that, and that will get us to the center point of our gear frame piece. So we're going to close that, and while that's finishing computing, I just want to make sure that I'm going to get this to line up with all of my pre-existing holes. So you're going to want to make sure you have a construction line for this. So I'm going to be doing this kind of a dumb way by just having Fusion 360 add all the numbers together instead of figuring it out myself. Okay, so you're going to want, so the radius that the holes for the gear frame are 54.5 millimeters out, and then these guys are 2.5, so we're going to want to set those just to 5. There we go. And it's super easy to get in the rest because all you have to do is tell it that you're making a circular pattern, and there you go. Now extrude this out. The thickness, actually we want that, yeah. You want to leave this center hole round so that way it can slide over that lower lock there. And I believe the thickness that I allotted for this was 2 millimeters. Let me double check that though. Measure from here to there. Yep, 2 mil. All right. So this top frame, so that's those holes right there are really all you need to lock this tourbillon in place. It doesn't look very good. In fact, I'm actually going to go into opacity control and turn it down to just 40% permanently so that way we can see through it. And you can see it rides on that center shaft right there. And that is what allows the tourbillon to stay in line, and it will also, just due to the virtue of being attached to the gear, keep the gear in line. So there are a few more things though that you'd want to do before you just say, all right, we're done and good. And that is, one of them is put in the center axle here and actually connect the gear to something. So we're going to put in axle, new component called axle, and lower frame. There you go. And we're going to draw a new sketch on the very bottom of the gear. We already set the axle for right there to be 10. We're then going to go out 15, and then out also 25. That seems like a decent number. We're going to turn on another construction line, and here is where we actually have to decide how big we want the gear for this to mesh into. So because we're working in module 2 for the gears, the distance from this line right here, whatever that distance is, we divide that in half, and that's the number of teeth that the gear is going to mesh with. So we're going to set that to 15. That will put it right on that line. And let's do a 30-toothed gear. So we're going to put that 60 millimeters away, and that actually puts it right on the edge of this imaginary frame. We're going to turn the construction back off because we do want this to be a real line. 25 again, 15 again, and 10 again. Now you're probably wondering, why do we have all of those like concentric rings going in? It will make sense right now, actually. So, but we're going to want to turn on the cross-section analysis so that way we can see inside, so we know what we're doing. So we extrude this guy up the 8 millimeters to make him fit inside of the gear. So that's the axle itself. Then the 15 is because we want there to be like a 1.5 step before we have the big main bulk part of the frame. We need to spend a day and you need to show me how to use Fusion 360. Yeah, probably. It's a bit of a learning curve to get it to run. It's just learning where all of the tools are and how to use them. Well, and what they do. Because I'm going to be going back into this sketch command in a second to finish making this lower frame piece. But you can see I'm doing it pretty darn fast, and that's mostly due to just I know where everything is. But then for this, so we have that little step right there, and we're actually going to want to do an offset and just lower that down by the 1.5 that we had that step be, and then 2.5. So you can see that little step right there reduces the amount of surface contact between the gear. My 3D modeling experience is a little bit of SketchUp and a fair amount of Kerbal Space Program. Does Kerbal Space count as 3D modeling? Dude, I hate I hate SketchUp though. It's like if all you have is the sketch command and the extrude command, and both of them are broken. But so you can see that those three rings are the reason why I am a god at SketchUp. Can Blender be? Oh yeah, absolutely. Blender can absolutely be used to. There's a guy that modeled an entire clock in Blender. Oh yeah, right here. So yeah, you can see this dude modeled this whole thing in Blender. Mainly is used for animation though. Like that's the main thing Blender is good at, because it's a mesh modeling software. Yeah, so you can see all of these little line segments here. But I actually forgot a little trick to, because these are basically the same axle, I'm just going to actually go through and select everything on both, so that way they stick through and down all the way. See? Yeah, there we go. But what we're going to want to do is make these connected to each other. And my preferred method of actually doing that is to create a 3-point arc and make it tangent on the outer most ring. Then click on the endpoints with this coincident, and that will make it so that you can drag this guy around, and it will always have a nice smooth transition between the curve and the actual circle. And then to actually get it to lock in place, that right there is basically the radius of whatever the circle is. So we're going to make another construction line. You can hit X to automatically make those. And we're just going to be setting basically an arbitrary dimension on that. So you can see now we have that nice curve right there. And then we're going to just mirror that line over that center construction. Finish sketch. And then we're going to actually include on this bottommost piece, bottommost extrusion, that center bit. And because we started the sketch on the face of the gear, we're going to have to go through and make sure all those little bits are selected. Turn that off. And let's take a look. So we now have our little gear guy on a frame piece to serve as an axle. We're going to make another gear. We wanted it to have 30 teeth, so we just changed the number of teeth to 30, hit enter, and it will generate this. That looks real close. I forgot to divide it in half. Yeah. We're going to want to go back. So instead of 30, it's actually going to be a 60 tooth, because I put in the radius. But no matter. Move copy. And we're going to want to move this guy over the 75. And I'll put him right centered over that axle. You can see. And the reason why you move it over 75 is because it's 15 for this gear, 30 for this gear. I'm actually going to be generating this gear one more time because I can put in the whole diameter, and that way I don't have to sketch one later. Move that right down there, and there you go. So as this gear right here would turn, this would turn, this little gear here would turn, which meshes with the tourbillon, which the frame is held in place, making it so that it has to turn in order to run. But yeah, there you have it. That's all that it really takes to hook up one of these tourbillons to a external power source, and hopefully this is giving you guys enough information to actually go ahead and use this in your own stuff. So yeah, bye.